At Wirreanda Secondary School, we've invested heavily in STEM practices with our students. It's the ideas, methods and values around STEM that we see as the way forward for our students and the way to get them into successful university courses and also prosper in those demanding professions that are available now and also going to be more available in the future. I saw that combat robots offered an opportunity for our students to be engaged in authentic activities which allowed them to problem solve and to go through iterative design in something that was challenging to them but also had a lot of authenticity.
I've been building combat robots since I was in primary school, and I've learned lots about how to design, build and use electronics within them. While doing this, I learned lots of skills with collaboration and teamwork. When Wirreanda approached me, I jumped at the opportunity to co-teach and build a product so I could share my love of combat robots with other students.
So, today's the start of the next 5 weeks of what we're going to do in terms of combat robots. And Jaden is going to introduce you to Raptor Robots. I've invested in Jaden's product, which he's developed, which you guys are going to have the benefit of using. This is going to immerse you in combat robots. It's going to be up to you to get as much from these guys as possible, particularly from Jaden with his expertise. I'm not an expert in this, as I've told you in the other things we do. This is about a shared learning experience, and this is a digital leader course. This is about you developing into that, and I learn with you. That's the whole idea of this course. So for some of you today, this will be like, wow, this is amazing. For others of you will go, it's not really my thing, but I get it. And as long as we get somewhere on that spectrum, that's fine. Yeah? So this is not my bag. I don't spend the weekend doing this kind of thing. But what I do see is this is immensely powerful in looking at design and looking at bringing digital and physical things together. And also that thing we've talked about with regards to iteration, continually going through some things. So I'm not going to steal any more thunder. I'm going to hand it over to Jaden and we'll go from there.
Sure. Hi everyone, my name's Jaden. Right button. Alright, so I have been building robots since I was in primary school, and I love to build combat robots. So the aim of this program is to get you all to learn about design, evolution, CAD, electronics, and then with that knowledge you're going to apply it in building your own combat robots. So now, what sort of weapons do you think combat robots could have? So we're going to give out a sheet which has a bunch of images and a bunch of names, and you're going to try to match them together. So how do these robots work? So there's very common parts within it. So you have things like wheels, which make you move, motors, and behind them you have what's called an ESC. So an ESC is an electronic speed controller. So then you've got your main PCB. Does anyone know what PCB stands for? It's right there. Yeah. So it's a printed circuit board. Just makes everything a lot more tidy and neat. You've got 5-volt regulators, keeps everything the same voltage. Resistors, stops your LED from exploding. Switch turns it on and off. Battery, so on and so on.
Alright, so let's go over here then. Who's going to come forward and try and battle Jim?
We all know he's going to win.
So stay in the masking tape. First one to get pushed out loses.
Wait, simmer wrestling. He's already winning. He's not out yet. Yeah, now he is.
Yeah. Oh, got him. Oh, you won.
Oh, did I? Yeah. Oh, I won.
Maybe. I don't know, it's also the robot. It depends what gear ratio, you know. Like, these are pretty slow compared to other robots. A simple question, what kind of design features do you think your robot might have?
Protection.
Oh, so you're going down the protection room, okay.
Flipper?
Flipper? Alright. All of these things you've got to should be swimming around your head now, because you're about to go into design mode now, where you're basically going to have to come up with your first iteration of design. But before you do that, you need to do research. So, for the remainder of this lesson, we're going to be focusing on that research. That's why you've got to
like 5 minutes to help some teachers something. Just leave the top.
So design battle. That's where we're going from, forward from here. All right. Jaden, anything else you got to say?
I hope you all had fun. That's it.
Thanks a lot, Jaden, for your time. Yeah, they'll black them out. It's for their purposes. Jaden is a student at Norwood Morialta in Year 9, so the same age as you guys. And for those people who weren't here last time, he's been doing this since he was in primary school and has vast experience in combat robots. Now, the two things we're going to be dealing with today are we're going to be dealing with furthering the designs, further iterations, and I'll talk about where you've got to and what's happened with that, and a bit of the 3D printing that's happened and the issues with that, and then soldering. You're all going to have a go at soldering.
So there's soldering and there's solder. So solder is an alloy, which is low temperature, which is great for soldering. It's also conductive, which you'll probably have in your hands now. It's a little bit of solder. And then once we heat it up with a soldering iron, it turns into solder. Just go to the side view. Alright, so is that flat? Yeah, that's flat to the bottom. So your motor, so it's 10 tall, and then in the middle is your axle. So will that fit? So how tall is this whole thing? Is it 30 or 35 or 20? 40. Alright. So how big are your wheels? 40. So you'll have no traction. So how are we going to fix that?
Make it a bit smaller.
Yeah, so instead of shrinking it down, just cut the top off with a box. You've got holes there, so that's good. So it should work, in theory. So you want to double check all your measurements, see that that's centered, and then you're good. Yeah, place it down, heat it up, like that. Okay. So that's a good weld, that's a good joint. Ish. I'm sure some of you could probably do some better soldering. Pins to about a 45-degree angle so that they don't fall out. And then just solder. Yeah, and then you solder all 3 pins. Put that over here. Okay, you guys done? Okay. So grab your motors out. Goes in this way. Juggling part of put this on. Okay, now we're going to bind them together. Once you've got your battery plugged in, you go. Hold that button down, turn it on. It should say RX binding.
Say it there.
Okay.
Write your name on it.
You built that.
Oh, if you put it in your box, you can put it on your box like that, you know?
Yeah, just knowing that you're not fighting anything incorrectly. Yeah. There's a reason you're testing everything.
How was it? He's good, bro. Quit my job. You can't quit your job.
It's your way now, Jess. You could have altered it between now and then. You just secretly.
Yeah, just knowing that you're not fighting anything.
Judge you on what criteria, Judge?
Control, damage, and aggression. Okay, ready? 3, 2, 1, go.
Remember the 10-second holding rule, people?
Oh,
So like after 10 seconds?
you can get stuck under there, remember. Oh, one splits.
Oh, aggression.
4, 3, 2, 1. Oh, that's it. We have our winner. 3, 2, go.
Surprisingly.
Oh, aggression.
Brendan.
Oh, push into the wall. It's a very close competition.
Nearly over the ring.
If they get stuck for 10 seconds.
If he doesn't move for 10 seconds, then that's it. You lose.
So pushing that.
The walls are solid.
Dancing.
Matters a lot.
Oh! Push him out.
Get that traction.
Yes!
Oh!
Keep going!
Lucky! Pushing over!
Look at that! Come on.
Halfway through the match. Three, two, one. We have our winner! Grand finals between Arsenal and Dalroy.
Ciao, robot.
We're going to start. In 3, 2, 1. Activate. Hey, good pushing. Oh, pushing against the wall. Good tactic. A lot of control here. Oh, 3, 2, 1. We have a oh, too late. An award for best design. I think we have came to a decision.
Should be Nathan's.
Okay, we have our winner.
It should be Nathan's.
Bruh.
Yeah.
Yeah, come out front here. We'll give you an award.
Creative front-end design, limiting antenna, and also...
Second place. Okay, where's cool? Okay, finally we have our winner for our tournament today. Dark Robot, come on forward, you and your teammates. Woo!
Yes. Congratulations.
Everybody who won had a teammate.
3, 2, 1, activate.
Oh, there's a flipper in there. No, what? Carnage. A big city. I'm jumping Russian. I reckon it's going to cost. I reckon it's going to cost.
Right, everyone say combat robots. Combat robots. Hey, nice one.
Okay, so let's get ready for the Grand Smash finale then. Everybody in. Everybody in.
It was a challenge ensuring that the kits and all the learning materials were ready for the session. But it was worth it seeing the response from the teachers and the students. It was awesome seeing my love of combat robots and seeing the outcome of all these students and their combat robots. I believe I created high quality education material which worked well for the students.
This wasn't your typical project where you just buy some off-the-shelf tools and then you use them in the classroom. This was much more than that. The authenticity of working with somebody who could bring their expertise to the programme to deliver something that gave authenticity, that allowed the students to be involved in a challenging environment where they were able to design and redesign and engineer and have creativity, but also develop various skills within the process as well. And then as a teacher to be able to develop my learning and my teaching skills with somebody with expertise in a particular area. That was the beauty of this project. That's what made it so successful.